This is SpaceTime Series 28, Episode 29, for broadcast on the 7th of March 2025. Coming up on SpaceTime, could Jupiter's moon Callisto be another ocean world? Using lasers to try and identify ancient life on Mars. And claims the International Space Station's cleanliness might be making its crew sick. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
As astronomers explore more and more of the outer solar system, they're finding that ocean worlds appear to be quite common, and now there's another that they can add to that growing list, the Jovian moon Callisto. If confirmed, Callisto will join the likes of Ganymede, Europa, Enceladus, Titan, Triton, Ceres and Pluto, to name just a few, which are all thought to have liquid water oceans beneath their icy crusts. Callisto is Jupiter's second biggest Galilean moon, and it's more pockmarked with craters than just about any other object in our solar system. NASA's Galileo spacecraft back in the 1990s captured magnetic measurements of Callisto, suggesting its ice shell surface may be covering a salty liquid water ocean. But the evidence has actually remained fairly inconclusive. That's because Callisto has an intense ionosphere. Now, a new study reported in the journal AGU Advances has provided a more in-depth review of the data, examining all 8 of Galileo's close flybys of Callisto, which more strongly suggests that Callisto does in fact harbour a subsurface ocean. But as well as looking at the flyby data, the authors of the study also undertook more advanced computer modelling of Callisto's ionosphere as well as its geophysical properties in order to determine if a subsurface ocean is compatible with the available information. They found Callisto's ionosphere alone couldn't explain all the existing observations, but that a subsurface ocean in combination with the moon's ionosphere could. The authors think Callisto's ocean is likely to be at least several tens of kilometres deep. It's encased beneath a solid ice shell that itself could range from tens to hundreds of kilometres thick. These new findings are setting the stage for additional studies by both NASA's Europa Clipper spacecraft and the European Space Agency's JUICE Jupiter Icy Moons Explorer mission, both of which are currently on their way to the Jovian system. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, using lasers to try and identify life on Mars, and a new study suggests that the International Space Station's cleanliness might be making its crew sick. All that and more coming up on SpaceTime. A new study suggests that lasers could be used to try and identify the fossils of ancient microbial life on the red planet Mars. The idea comes about because scientists have now successfully used lasers to identify microbial fossils in gypsum rocks here on Earth. And because gypsum samples on Earth are a close analogue for sulfate rocks on Mars, it raises the possibility of also using lasers to search for fossils on the red planet. Billions of years ago, water on Mars dried up, and gypsum and other sulfates were formed when pools evaporated, leaving behind minerals that precipitated out of the water and potentially fossilized any organic life that may have existed there. This means that if microbes such as bacteria lived on Mars, traces of their presence could be preserved as Martian fossils. Now, according to the authors, gypsum deposits formed on Mars could conceal evidence of past life on the red planet, microbes similar to that first life that formed on Earth 4 billion years ago. So how did they reach their conclusions? Well, the authors selected a miniature laser-powered mass spectrometer that was light enough to travel on a spacecraft, yet capable of analysing the chemical composition of a sample in detail as fine as just 1 micrometer. They sampled gypsum from a quarry in Algeria, analysing it using a mass spectrometer and an optical microscope guided by criteria which can help distinguish between potential microbial fossils and natural rock formations. These include morphology which is irregular, sinuous and potentially hollow, as well as the presence of chemical elements necessary for life, carbonaceous material and minerals like clay or dolomite which can be influenced by the presence of bacteria. They successfully identified long, twisting fossil filaments within the Algerian gypsum, which have previously been interpreted as cyanobacteria and are now thought to be sulfur-oxidizing bacteria. These were embedded in the gypsum and surrounded by dolomite, clay minerals and pyrite. The presence of these minerals in the earth rocks signals the presence of organic life because prokaryotes, that is cells without a nucleus, supply elements which clays need to form. And that also facilitate dolomite formation in an acidic environment like Mars by increasing the alkalinity around them and concentrating ions in their cell envelopes. For dolomite to form within gypsum without the presence of organic life, extremely high temperatures and pressures would be needed that would have dehydrated the gypsum, and these simply are not consistent with our knowledge of the Martian environment. A report in the Journal of the Frontiers in Astronomy and Space Sciences claims that if mass spectrometers can identify the presence of clays and dolomite in Martian gypsum, in addition to other biosignatures, this could be a key signal of fossilized ancient life on Mars. This is SpaceTime. Still to come, a new study suggests the International Space Station's cleanliness might be making its crew sick, and the Mars equinox, the constellations of Taurus the Bull and Leo the Lion. And don't forget, it's almost 3.14159. That's Pi Day. All that and more coming up on March Skywatch. A new study suggests the International Space Station's cleanliness might be making its crew sick. Astronauts often experience immune dysfunction, skin rashes and other inflammatory conditions while travelling in space. Now, a new study reported in the journal Cell suggests that these issues are likely due to the overly sterile nature of the International Space Station. The authors believe the introduction of a higher diversity of microbes onto the station could counterintuitively improve the health of people living aboard the orbiting outpost. To work this out, the authors got the crew of the International Space Station to collect more than 800 samples from around the station and then bring them back to Earth. They then identified which bacterial species and chemicals were present. They found there were far fewer free-living microbes on the station, and the authors suggest the intentional introduction of more of them could help improve the astronauts' health without sacrificing hygiene. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for March on Skywatch. Happy New Year! Well, it would be if this was ancient Mesopotamia or Rome. That's because March was the first month of the new year, going back to the earliest concept of celebrating New Year's Day at the time of the vernal equinox, around 2000 BCE. See, the ancient Roman calendar, which had just 10 months, designated March 1st as the new year. That 10-month calendar is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It wasn't really until the Gregorian calendar that January 1st marked the start of the new year. But in the beginning it was mostly Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated New Year's Day on March 25th. The highlight of this month is the March equinox, which would take place on the evening of Thursday, March the 20th Australian Eastern Daylight Time. That's 5:01 in the morning of Thursday, March 20, US Eastern Daylight Time, and 9:01 a.m. Greenwich Mean Time. For our listeners in the Northern Hemisphere, it means the vernal equinox, the start of spring, while those south of the equator it's the autumnal equinox, meaning a move into autumn. The day marks the point in Earth's orbit around the Sun, when the planet's rotational axis means the Sun will appear to rise exactly due east and set exactly due west to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the very word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. That axial tilt is always pointed at the same position in the sky, regardless of Earth's orbital position around the Sun. So, on any other day of the year, either the northern or southern hemisphere are tilted more towards the Sun, But on the two equinoxes, usually around March 21st and September 23rd each year, the tilt of Earth's axis is directly perpendicular to the Sun's rays. However, there's a complication called precession. This causes Earth's spin axis to wobble ever so slightly, just like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. And because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the Southern Hemisphere autumn, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subjected to small changes called perturbations. See, Earth's orbit's an ellipse, and there's a slow change in its orientation which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion gradually regresses through a 21,000-year cycle. And there's another complication. Australia and some of the other Commonwealth countries start their seasons on the first day of the month, what are referred to as meteorological seasons, rather than on the solstices and equinoxes, which are referred to as astronomical seasons. So that means Australia's autumn officially began on March 1st rather than on the day of the March equinox. Meteorological seasons are used because it makes it easier for meteorologists and climatologists to break the seasons down into more exact 3-month calendar groupings for comparing seasonal and monthly statistics. The moment of the March equinox is also important in astronomy because it's used to define the celestial coordinate system of right ascension and declination. In astronomy, the celestial coordinate system is the astronomical equivalent to the latitude and longitudinal coordinates used on Earth's surface. It's used to specify the position of objects in three-dimensional space and the direction of those objects on the celestial sphere, the imaginary globe surrounding the Earth. In other words, it lets scientists determine the position of a celestial object, such as a satellite, a planet, stars, galaxies, and so on. Right ascension, which uses the symbol alpha, is the angular distance measured eastwards along the celestial equator from the vernal equinox. On the celestial sphere, it's analogous to terrestrial longitude. Declination, which uses the symbol delta, measures the angle north or south of the celestial equator, and so it's the celestial equivalent to terrestrial latitude. Marking the vernal equinox and setting the western evening sky this time of year is one of the oldest recognised constellations in the heavens, Taurus the Bull, so named around 6,000 years ago. In Greek mythology, Taurus represents the king of the god Zeus. Zeus lusted after King Agenor's daughter Europa, who was looking after a herd of cattle. Now, being a god and with godlike powers, Zeus decided to transform himself into a powerful white bull so that he could get closer to the beautiful Europa. Now, once transformed into a bull, Zeus convinced Europa to climb on his back, and he then carried her off to the island of Crete. Taurus's head is represented by a dominant V-shaped grouping of stars. The bright reddish star in the group is Aldebaran, an orange giant 1.5 times the mass of the Sun, located 65 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Aldebaran is the 14th brightest star in the night sky and the closest bright star to the point of the vernal equinox. In ancient Arabic, Aldebaran's name means the follower, as it appears to follow the 7 sisters of the Pleiades. It's also the first of the 4 royal or guardian stars identified by the ancient Mesopotamians. Now, that V-shaped grouping of stars near Aldebaran is known as the Hyades. It's the nearest young open star cluster to Earth, located just 153 light-years away. Between Aldebaran and the Orion constellation, you'll see a bright red star. That's Betelgeuse, the 9th brightest star in the night sky, these days more commonly called Betelgeuse. If you turn to the north now, you'll see the 2 bright stars Pollux and Castor, which represent the northern constellation of Gemini, the twins. In Greek mythology, they were brothers who travelled with Jason aboard the ship Argo in search of the Golden Fleece. Pollux is an orange-hued evolved giant star, located 34 light-years away. It has about twice the Sun's mass and is bloated out to around 11 times the Sun's diameter. In 2006, an extrasolar planet or exoplanet, designated Pollux b, was discovered orbiting the star. The planet is a gas giant, orbiting its host star every 1.61 Earth years. The other star, Castor, is located some 51 light-years away, and it's actually a system of 6 stars comprising 3 eclipsing binaries. Eclipsing binaries are binary star systems in which the orbital plane of the 2 stars in the system lies so nearly along the line of sight from the observer here on Earth that the stars appear to eclipse each other. Looking to the northeast now, and you'll see the star Regulus, or Little King, the brightest star in the constellation Leo the Lion. Leo is mentioned by Homer in his famous 8th century BCE poem, the Odyssey. According to Greek mythology, Leo was killed by Hercules as the first of his 12 labours. Located some 79 light-years away, Regulus is a multiple star system composed of at least 4 stars. Regulus A, designated Alpha Leonis, is a spectroscopic binary comprising a rapidly spinning spectral type B blue-white star around 3.5 times more massive than the Sun, with some 288 times the Sun's luminosity, and a small companion star, most likely a white dwarf, the stellar corpse of what once would have been a Sun-like star. The pair take about 40 days to orbit each other. Spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our viewpoint here on Earth at least, by their spectroscopic signatures. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then spectral type G yellow stars. That's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Each spectral classification system is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So, our Sun technically is a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can have around 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. The primary star in Alpha Leonis completes a full rotation around its axis in under 16 hours. That's incredibly quick, especially when compared to our Sun's 30-day rotational period. Now this gives the primary star an oblate appearance, and it causes what's known as gravity darkening, meaning its poles are considerably hotter and 5 times brighter per unit surface area than its equatorial region. Scientists estimate that if it were rotating just 15% faster, the star's gravity would be insufficient to hold it together, and it would literally spin itself apart. Located further away are Regulus B, C and D, which are all dim main sequence stars. Main sequence stars are those undergoing hydrogen fusion into helium in their core, like the Sun's currently doing. Regulus B and C are thought to orbit each other every 600 Earth years and are located around 5,000 astronomical units away from Regulus A. An astronomical unit is the average distance between the Earth and the Sun, around 150 million kilometres or 8.3 light minutes. Regulus B is a spectral type F white-yellow star, while its companion Regulus C is a small spectral type M red dwarf star. Regulus D is a bit more of a question mark. It's a dim star, and, at least from our point of view, it appears to be sharing motion across the sky with other members in the group. At the opposite end of the constellation of Regulus is the star Beta Leonis, or the nebula, the horse's tail. It's a luminous white star thought to be spectral type A, about half as bright as Regulus, and the third brightest star in the constellation Leo. Beta Leonis has about 1.8 times the mass of the Sun and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Eta Scuti type variable star, meaning its luminosity varies very slightly over a period of several hours due to pulsations on its surface. Also at the other end of Leo are the stars Theta and Iota Leonis, the loins of the lion. Theta Leonis is about 165 light-years away. It's a very young spectrotype A white star, about 2.5 times the mass of the Sun. With an age of just 550 million years, Theta Leonis' spectra shows enhanced absorption lines for metals, that is, elements other than hydrogen and helium. This increased metallicity appears around 12% higher than the Sun, allowing the star to radiate with some 141 times the luminosity of the Sun from its outer atmosphere, at an effective temperature of 9,350 Kelvin, literally giving it a white-hot glow. Located some 79 light-years away, Lota Leonis is another spectroscopic binary, consisting of 2 stars orbiting each other every 183 Earth years. The primary star is a spectrotype F yellow dwarf star, a little hotter and more massive than the Sun. Algebra, or Gamma Leonis, is a binary star system with a visible third component. The 2 primary stars are located 126 light-years away and can be resolved in a backyard telescope. Both are yellow giants, orbiting each other every 600 Earth days. The unrelated tertiary star, named 40 Leonis, is a yellow tin star which can be seen through binoculars. Its traditional name, Algebra, means the forehead. Other stars in the system include Delta Leonis, or Zosma, which is a blue-white star 58 light-years from Earth, Epsilon Leonis, a yellow giant some 251 light-years from Earth, and Zeta Leonis, an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and is located to the south of the primary, with the third and faintest star in the system, 35 Leonis, located to the north. Also located in Leo is Tau Leonis, visible as a double star through binoculars. It includes a yellow giant located some 621 light-years from Earth, and a binary secondary star 54 Leonis, a pair of blue-white stars divisible in small telescopes and located 289 light-years from Earth. Also in the constellation Leo, you'll find the Leo triplet, a group of 3 galaxies, Messier 65, Messier 66 and NGC 3628, all appearing relatively close together. Messier 65, also known as NGC 3623, is an intermediate spiral, possibly barred spiral galaxy about 37 million light-years away. M65 disk appears to be slightly warped, and a relatively recent burst of star formation is suggestive of some gravitational interaction with the other 2 galaxies in the Leo triplet, possibly around 800 million years ago. Nearby is Messier 66, or NGC 3627, another intermediate spiral galaxy, some 95,000 light-years wide and about 36 million light-years away. Gravitational interaction from its past encounters with the neighbouring galaxies in the triplet has resulted in an extremely high central mass concentration, a high molecular to atomic mass ratio, and a resolved non-rotating clump of neutral atomic hydrogen apparently removed from one of its spiral arms. The third member in the group is NGC 3628, the Hamburger Galaxy, a spiral galaxy with a spectacular 300,000 light-year long tidal trail of gas and stars. NGC 3628 is located 35 million light-years away. Its most conspicuous feature is the broad and obscuring band of dust located along the outer edge of its spiral arms, effectively transecting the galaxy to the view from Earth. Other bright well-known galaxies in Leo include Messier 95, Messier 96, Messier 105 and NGC 2903. M95 and M96 are both spiral galaxies, each about 20 million light-years from Earth. M95 is a barred spiral. Another barred spiral galaxy is NGC 2903, which is thought to be very similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also around 20 million light-years from Earth. Okay, let's turn to the east now and the constellation of Corvus the Crow. In Greek mythology, Corvus was a really clever crow. In fact, he could talk to people. However, after refusing to speak to the god Apollo, he was banished to the sky, together with Crater the Cup and Hydra the Snake. One of the brightest stars in Hydra is Alphard, the solitary one, so named because it appears all alone in the sky. Okay, turning to the western horizon now, and you'll see the star Achernar in the southern tip of the constellation Eridanus the River. Eridanus is one of the largest and longest constellations in the sky. Achernar means the river's end, as it marks the end of the river Eridanus. Located around 139 light-years away, Achernar is a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. One of the 10 apparent brightest stars in the night sky, Alpha Eridani A is a young, hot spectral type B blue star, about 6.7 times the mass of the Sun, with a stunning 3,150 times the Sun's luminosity. Achenar's extremely high rotational velocity of over 16 kilometers per second gives it an oblate shape, making it one of the least spherical stars in the Milky Way, with an equatorial diameter some 56% greater than its polar diameter. This distorted shape means the star displays significant latitudinal temperature variations, with its polar temperature being above 20,000 Kelvin, while its equatorial temperature, being much further away from the stellar core, is only around 10,000 Kelvin. Those high polar temperatures are generating a fast polar wind, ejecting matter from the star and generating a polar envelope of hot gas and plasma. The companion star, Alpha Eridani B, appears to be a spectral type A white star with about twice the mass of the Sun. The two stars orbit each other at an average distance of roughly 12.3 astronomical units. Now, just a quick reminder that March 14th marks the yearly celebration of the mathematical constant pi. Pi is the ratio of a circle's circumference to its diameter. But it's also an irrational number, meaning its decimal representation never ends and never repeats. More than just a number, pi has important applications in astrophysics, orbital mechanics, and other fields of astronomy. It's been calculated to over 1 trillion digits, and the current record for reciting pi from memory is over 70,000 digits. Imagine sitting next to that person at a dinner party. As for me, 3.14159 is about it. Of course, as well as Pi Day, March 14 is also the birthday of the great Professor Dr. Albert Einstein. And joining us now for the rest of our tour of the March night skies is science writer Jonathan Nally.
G'day, Stuart. Well, I reckon this is a fantastic time of the year for stargazing, March, because where I live in the southern hemisphere, we're just coming out of summer, so the weather is still good and the nights are still warm enough for getting outside and looking up. For our friends in the north, their wintry conditions are still biting perhaps, but the sights you can see in March are well worth enduring even the cooler nighttime conditions that you still have, because there are lots of great things to see. And we'll start in the northern part of the sky, as seen from down here south of the equator. And the first thing we spot, of course, is the mighty constellation Orion. It's one of the most easily recognisable constellations. For a start, it's got these 3 stars in a row. You can't miss them. I mean, you might think, you can look up and see any 3 stars in a row, but these 3 stars are very close together and they're in a straight line, and that's known as the belt of Orion. Because Orion, mythology of Orion is the hunter. So there's this big hunter up in the sky. So this is around his middle, this is his belt, and extending southwards from the belt are a few stars and a little fuzzy patch, and together that's known as the sword of Orion, because the sword is hanging down from his belt. That fuzzy patch is the amazing Great Nebula in Orion. It's a huge star-forming region about 1,300 light-years from Earth, and you've probably seen pictures of it. And if you haven't, you can just get on the internet and just see plenty of pictures of it, and Hubble and that sort of thing. It looks amazing. Just see it with your own eyes. If you just want to see this Great Nebula of Orion with your own eyes, go outside and let your eyes dark adapt for about 20 minutes or so. That means just keep away from all sources of light. Don't look at lights, because as soon as you look at lights, you blind yourself again. When you're doing stargazing, you've got to let your eyes adapt to the dark. Just keep away from lights, street lights, any lights on the outside of your house or the neighbour's house, whatever. Try and get into somewhere shadowed where you just don't have any lights, and then you'll be able to see the faint stuff, because the Orion Nebula is faint and it's small and fuzzy. So get out there, once your eyes are dark adapted, and see if you can see this nebula. It'll just be the tiniest smudge of light, and you might have to use what's called averted vision. Astronomers use this a lot, averted vision. That's where you don't look directly at it, but look at it sort of out of the corner of your eye. The sort of outside part of or the outer part of your retina has the light receptors that respond very well to very dim objects. They're good for nighttime stuff. You don't get colour out of them, you just get black and white, but they are more sensitive to very faint light levels. So give that a try. And even though it seems small and tiny and fuzzy without using a telescope, it is actually amazing to think that we can actually see this huge nebula 1,300 light years away with just our eyes. If you compare what you see with your eyes and then look at a picture of it, you think, wow, that is amazing that I can see that. And if you've got a pair of binoculars, that'll give you an even better view. And even a small telescope will provide an amazing view. So give that a try if you've got a small telescope, or if you know someone who has, you can borrow it or go over and use it with them. Also visible in the northern part of the sky if you're looking from the mid-latitudes in the southern hemisphere, or it's in the southern part of the sky if you're looking from corresponding latitudes in the northern hemisphere. There are a bunch of constellations of the zodiac around at the moment. I mean, there always are, but these ones are really good ones. We've got Taurus, we've got Gemini, Gemini, Cancer, and Leo. Cancer and Leo, they do seem a bit bare for unaided, the naked eye stargazer, not using a telescope. But Gemini and Taurus are really good, actually. You can easily spot Gemini because it has two bright stars, Castor and Pollux. Gemini is the so-called constellation of the twins, and Castor and Pollux are these two bright stars that are fairly close to each other, and they're fairly close in brightness to each other as well. They're almost the same brightness, so they are the twin stars of Gemini. Taurus has a very recognisable wedge-shaped group of stars, star cluster called the Hyades. It's very easy to see, and on one edge of it there's a bright reddish star called Aldebaran, which is quite easy to spot as well. There's another star cluster in Taurus. It's called the Pleiades, or the Seven Sisters, which we've spoken about many times on the program, and you can see this with the unaided eye. You'll probably only see 6 of the stars, though, and you do need to give yourself that dark adaptation time. And also, you might need to use the averted vision, depending on how good your eyes are. Young people's eyes, they're really good. Older people like me, you need a bit of help. So get yourself dark adapted and use averted vision if you need to. Now, high overhead at this time of year, for those of us in the south at least, are the two brightest stars in the night sky. That's Sirius and Canopus. Sirius, the brighter of the two, is actually a double star system. You can't see the second of its stars. It's a tiny white dwarf. In fact, no one can see it, so don't worry about that, but it is a double star system. The larger of its two stars, the one we see, it's twice as massive as the Sun, and yet although Sirius appears around twice as bright as that other star, Canopus, the second brightest star, Canopus actually is intrinsically much brighter than Sirius. It just seems dimmer than Sirius because it's a lot further away. Canopus is about 310 light years from Earth, whereas Sirius, the intrinsically dimmer star, is only 8.6 light years. So it's quite nearby in space terms. That's why it seems brighter than the actual brighter star, Canopus. But they're both beautiful stars. They're great. You really can't miss them. They are big and bright. Now, going south along the Milky Way past Sirius and Canopus, heading down into the south now, we come to the far southern constellations, such as the Southern Cross and Carina. The Southern Cross is lying on its left-hand side at the moment in mid-evening during March. But if you're awake around 2 o'clock or 3 o'clock in the morning, if you're stargazing then, you'll find it much higher in the sky and then standing straight up. That other constellation I mentioned, Carina, it has another big nebula that you can see with the unaided eye, like the Orion Nebula, but this one is big. It is really, really big. Get out after midnight if you can, when there are fewer lights around. Let yourself get dark adapted, and you will see the Carina Nebula with the unaided eye. It's enormous, and then if you get a small telescope onto it, you can just spend hours sort of sweeping around this huge region of nebulosity out there in space. It is. Everyone raves about the Great Orion Nebula, but really, I think the Great Nebula in Carina is probably the better of the two.
Certainly fascinating when you think of the ticking time bomb inside the nebulosity. The two stars there that are both big blue supergiants that are about to explode.
They are. When we say about to explode, of course, we don't mean like tomorrow or the next week or whatever, or that, I suppose it.
Well, it could be.
It could happen. It could happen. But likely, of course, it's going to be a long time from now. But yeah, in space, in astronomical terms, and in stellar evolution terms, yeah, they're on the way out. And any day now, in terms of, the eons, they're going to go bang. That'll be pretty impressive.
They'll be bright enough to be seen in daylight, probably as bright as the moon is in daylight.
Yeah, that would be really impressive. I mean, nighttime would be almost daytime. It'd be really, really bright. You wouldn't have any trouble reading a book outside, that's for sure. You'd probably have to wear sunglasses, in fact, Stuart. Now, turning to the planets, we've got Venus. Venus is briefly visible right at the start of March, but it's very low down on the western horizon after sunset. And it's soon going to disappear from view. It's heading, as we see it from our line of sight, it's heading closer and closer to the sun. It's not actually getting closer to the sun, but it's in line of sight-wise, it's just getting closer. So we're going to lose Venus very quickly for all of March, basically. It will reappear in the morning sky just above the eastern horizon before sunrise early next month. So if you want to see Venus next month onwards is better time. Jupiter and Mars are very prominent in the evening sky after sunset at the moment. Jupiter can be found very close to that star cluster I mentioned earlier, the Hyades in Taurus, and also the star Aldebaran. It's close to those two, big and bright and white, and you really can't miss it. Mars, which is somewhat dimmer and has a sort of a ruddy, orangey sort of colour, it can be found not far from those two stars in Gemini, actually, Castor and Pollux. In fact, it makes a nice triangle with them. You've got pretty much almost an equilateral triangle now that I sort of picture it in my mind from the star map I was looking at earlier today. You've got Castor and Pollux as one base of the triangle, and then at the apex you've got Mars, so that should be pretty easy to spot as well. Finally, Saturn, unfortunately, is pretty much out of view this month, too close to the sun for viewing. The only time you're going to see it is in the last days of March, just above the eastern horizon before sunrise, but next month will be a lot better for those who get up before the dawn. And that, Stuart, is the sky for March.
That science writer Jonathan Nally, and this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.